Hello and welcome back to Gaffey's Grinds. In the previous lesson, we learned how to write a word equation to describe what's going on during a chemical reaction. In today's video, we're just going to make that idea a little bit more complicated by learning about something called chemical formulae. A reminder that when watching this video, you should turn your phone off or stick it somewhere where it can't distract you and close any open tabs that you've got. Now, to begin today's lesson, we're just going to begin with a quick recap question. And the reason for this is this builds into to today's idea. So I need to make sure that you definitely know how to do this. So what I want you to do is I want you to read the question carefully. I'm going to read it with you here. It says, in a reaction, so we're talking about a chemical reaction, cobalt reacts with chlorine. You have to write a word equation for this reaction. Okay, so you should know how to do this now. And a reminder that if you're just going to sit there and wait for me to do the answers for you, you're not going to learn anything. So I'm going to give you lots of things to do, and I need you to make sure that you try to do them yourself. So I want you to pause the video and have a go with this now. Okay, so let's write a word equation for this. Obviously, if we're reacting cobalt with chlorine, then those are our reactants. We're beginning with those. So we put these on the left-hand side, and this is cobalt plus chlorine. We know it's a chemical reaction because it tells us in a reaction. So we use an arrow to show it's a chemical reaction. Now it's not equals. Cobalt and chlorine do not equal something else because they might not react if I just put them together. Sometimes I have to give a little spark, like a little fire underneath it, heat it up to get it to react. So it's not equals. We have to use an arrow to show a chemical reaction is happening. So we know it's going to make a product, which we're going to show on the right-hand side. And to figure out what the product is, I told you the last day how to name it. You're going to put the metal element first, which if you check your periodic table, you should know how to find the metals and the non-metals by now. You look for cobalt or chlorine, figure out which one is the metal and which one is the non-metal. If you didn't do that, you can pause the video and have a look now. Okay, so you should find cobalt on the left-hand side of the step line, which means it's a metal. So it goes first. So it's cobalt. And then we put the non-metal second, cobalt, chlor, and we don't keep the end in INE because there's two elements in this compound that we're forming. It's going to make cobalt, chloride. So we end the name in ide. So that there is a word equation that describes what's going on in this chemical reaction. Now, of course, we call this here a chemical compound. What is a compound? Speak your answer to the screen on 3. Okay, I'm hoping that you're saying it's a substance made of 2 or more elements chemically combined, or a substance made of different types of atoms chemically combined. Okay, so that's what we mean by a chemical compound. Today, we're going to show you how, well, in a way, it's going to be a little bit more complicated for a while, but then you're going to realize the reason for it is to actually make it simpler for us. Okay, so chemical formula. What is a chemical formula? Well, I'm going to show you. Okay, so say we had a chemical reaction that makes this substance. So this is the product. This is the compound that's formed. Carbon monoxide. Carbon monoxide. Okay, so the first thing to do is have a look closely at the name and figure out what's in here. Well, obviously, it's made of carbon. So that must mean it's got a carbon atom. It's got one carbon atom. The next thing to note, using a different highlighter, is this word, mon. And mon, this word actually means one. Okay, mon. And then we've got this here, oxide. Okay, so we've got carbon monoxide. So what does the oxide mean? Well, that would mean an oxygen. We saw that last week when we had oxygen. When it forms a compound, we end it in oxide. So we've got one carbon and one oxygen, in other words. That's what this thing is made of. One carbon and one oxygen. So to write that, we're going to actually shorten it down so we don't have to write the whole word carbon monoxide every time. So I'm actually going to take, okay, so what quicker way have I got of writing these things? Well, I know in my periodic table, okay, I'm hoping that you can see that. I actually don't see my camera, but I'm holding my periodic table up. I know that this is a list of all the elements and it has got some chemical symbols. So every element's got a chemical symbol. So we can use the chemical symbols to write this in a quicker way. And I'm going to show you how to do that. So obviously, if we've got one carbon atom, then I'm just going to write it as a capital C. It's a capital C because the first letter of every element is always a capital, has to be a capital. If there's a second letter, So say, for example, chlorine. Chlorine also begins with a C, but it also has a lowercase l after it. And that's to show that it's different from carbon. But carbon is just C. Oxygen, if I go to the periodic table, is just O. And I know I've got one carbon and I've got one oxygen. So I'm just going to do capital C, capital O. This here is what we call a chemical formula. Chemical formula. And it's literally just a shorthand way of writing out the name of a compound or a name of an element. So if it was carbon, I just write C. If it was carbon monoxide, I write CO. It's made of CO. Now, an important thing to note here is that what we're not writing, and the only reason we're not writing them is because they're ones, is that it's actually C1O1, one carbon, one oxygen. But in chemistry, kind of like when we're in maths, we don't go around writing 1x for everything. We'll just write x. You've probably come across x's and y's in maths already. And we don't go around writing 1x, 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 1x. We just leave it as x. Everyone knows that that just means 1 times x. Well, in chemistry, it's the same. So if you've got one carbon and one oxygen, you just write C1, you just write CO. You can drop them ones. Now, in a minute, we're going to look at one where it's not one. And as you can see, I'll show you what we have to do then. Okay, so this is carbon monoxide. All right, let's do another one. Say we've got this guy here, carbon dioxide. So we do a reaction, and this is the product, carbon dioxide. All right, well, what's in here? Well, again, we've got carbon. Carbon means one carbon atom. That's what's here, one carbon atom. We've also got this, so I'll just highlight that in green again, one carbon atom. We've also got this word here, di, di, and that means 2. Di means 2, and then lastly, we've got this word, oxide, which again is the same as above, it just meant oxygen. So 2 oxygen. This is a little bit different from before. It's got the same elements, carbon and oxygen, exact same as above, but this time it's carbon dioxide. Now, how do we write this? Well, obviously, we write the C for carbon, and we know that really that's a C1, but we're not going to write that one because we don't need to. The next thing then is we're going to put the O to show the oxygen, but this time it's not one O, it's actually 2 of them. So I put a little 2 down here to show that there are 2 of them. So if you've got 2, or say if you've got 3, then it would be CO3 and so on. Okay, now that's how we do that. And again, it's a shorthand way, and it shows us what elements are in a compound and how many of them there are. That's why it's so useful here. This is going to be really useful later on. But CO2 means carbon and 2 oxygens. All right, so what I'm going to do is I'm actually going to get you guys to pause the video and take down these 2 examples. You can write the heading, writing chemical formulas. Writing chemical formulas. If you like, keep a heading on it. Take these 2 down as an example. Pause the video, do that now. All right, we're going to do a couple more now, okay? So this time we're going to look at this substance. Its name is hydrogen chloride. All right, so first of all, what's in here? Well, obviously, we've got this word here, hydrogen. So we've got one hydrogen atom. And we've got chloride. We've got one chlorine atom. Now, you might be saying to yourself, well, why is it not monochloride the same way as it was up here, or monchloride? And it's a good question. But the reason why we had to have mono and di up here is because carbons, as you can see from those examples above, they can make 2 different things with oxygen. They can make it with 1 O or with 2 O's. So we have to be specific which one we're talking about, carbon monoxide or carbon dioxide. So carbon can join with oxygen in 2 different ways, carbon with 1 oxygen and carbon with 2 oxygen. Hydrogen and chlorine only does it this way. So nobody ever gets confused. It's always H, 1 chlorine and one hydrogen. So we don't need to always say monochloride because it only ever makes this one, monochloride. Okay. All right, so what I want you guys to do is I've done this bit for you. I want to take this bit down, and then I want you to try and write down what you think the formula is going to be. You're going to need your periodic table. Write down what you think the formula is going to be. Pause the video and do that now. Okay, let's have a go. Okay, so hydrogen, we go to a periodic table, we find that the symbol is H. And we know that really that means H1, but we're not going to write that one. We don't need to. Okay, and then it's going to join with chlorine, and it's one chlorine. So the symbol for chlorine is a capital C. Sorry, capital C, and then a lowercase l. So HCl, this here is the formula, this here. If you got that right, well done. Now it has to be a capital H, a capital C, and a lowercase l. Okay, if you did this, H, C, and a capital L, then that is wrong, okay? Because that there is not part of chlorine. Remember, the first letter of an element is always a capital followed by a lowercase. So it's got to be like that. It can't be two capitals, okay? All right, let's have a go at another one. Well done. If you got that right, I'm going to give you two more to do now. I want you to do these ones. So we've got sodium chloride is the name. And it's got one sodium and one chlorine. So write down the name, the formula for that one, and do this one as well. We've got methane, this substance methane. And this is the gas that we burn in the science lab, in the taps that we use for the Bunsen burners, methane. And it's got one carbon and 4 hydrogen atoms, one carbon atom and 4 hydrogen atoms. And that one is quite tough, the last one. So have a go at them two for me now. Do that. Okay. All right, let's have a look at what it should look like. So sodium chloride. So first of all, the symbol for sodium is capital N, lowercase a, Na. And I know I've got one of them. So I could put a 1 there, even though technically we don't. Okay, so I'm going to put it there for now, and I'm going to rub it out after. Chlorine is Cl, and there's one of them. So it's NaCl, like that. Okay, and that, of course, will also be Cl1. But I don't want to put them ones in, because when they're ones, we're just going to leave them out. So it should be just NaCl, and it's all kind of one word, if you like. It's not Na plus Cl, it's just NaCl. Okay, let's do this one now, methane. 1 carbon and 4 oxygens. So 4 hydrogens, sorry. So we've got capital C for carbon, and of course there's only one of them. And then we've got H, capital H for hydrogen, and there are 4 hydrogens. So hopefully you remembered, you've got to show that there are 4 of them. We do this by putting a little 4 down here. That is correct. Well done. Now, again, if you wrote it like this, C, H, and a big 4 like that, then that is not correct. It's got to be little case. If you did it like this, C, H, 4, like to the power of 4, that is also not correct. Okay, so it must be subscript 4. This little 4 we call a subscript. Okay, that's the way it has to be. All right, let's have a look at it a slightly different way now. Okay, let's see, can we work backwards? So say we get the formula MgO. Our job now is to be able to figure out, well, what's actually in here. Okay, so what's actually in here? So first of all, remember that this really means Mg1O1. The ones just aren't written. So the next thing to do is actually to try and figure out what's in here. So what type of atoms and how many of each type are there? So this means that there is 1 magnesium atom bonded with 1 oxygen atom. And the last thing we need to do then is to name it. What's this going to be named? We've got a magnesium and an oxygen. So it's a 2-element compound. We put the metal first. Magnesium is a metal. So it's magnesium. And it's going to be ox. And we change the engine to oxide. Okay, so it's the same idea as before. Nothing really different about it, except up here, it's written down in its shorthand way. Okay, so this up here is written in a shortened version. Remember that the ones are not written, but they are there. So MgO means 1 magnesium, 1 oxygen, and that has a name of magnesium oxide. All right, so what I'm going to get you to do now is you're going to have a go at these. Actually, do you know what? Pause the video and take down how I've done that. Okay, and then 2 for you to practice. Just make sure you can do this. We've got Li. I want you to do that one for me. LiBr and KCl. Okay, so that's a capital A, a capital C, and a lowercase l. All right, so do them two the same way I've just done that first one. Pause the video and do that now. Okay, so you should only be watching if you've done these two. Okay, the same way, and you have a name. So you've told me what atoms are in here and how many of each type, and then you've named it. Okay, if you haven't done that, pause the video, make sure you do it. Okay, so I'm going to use an arrow to take it out here. I'm going to say what's in here. Well, again, I know that there's ones here, 1 and 1. I know that Li is all the same element because we've got a capital and a small. This is one element. And the same for the Br. It's a capital B and a small r. So this is one more element. No, if you think that this is 4 elements, L, I, B, and R are 4 separate elements, then this is wrong because I and R are both small letters, which means they belong to the element that came before it. So the capital Li is just one element. Okay, just making that very clear again. Okay, so Li means that there is one lithium. Br, well, there's no number, so it means that it's one bromine. Bromine. Okay, so the name of this compound, lithium is the metal, so it's going to be lithium bromide. Lithium bromide is the name of this compound. Well done, if you got that right, lithium bromide. All right, the second one, again, if you didn't get that one right, I want you to pause the video now, fix it, and then try and get ahead of me and do this one again to make sure it's right before I do it here. So pause the video and make sure you practice again to get this last one right. Okay, so let's have another look at this one. What's in here? Well, there is one potassium, and one Cl, and Cl is chlorine. So there's one potassium and there's one chlorine. All right, so what's this going to be named? Well, the potassium is the metal, so it's going to be potassium, and chlorine is the non-metal, so chloride. Potassium chloride is the name of this substance. Good, well done. If you got those right, it's time to do some mixed practice questions now. So we're just going to have a look over here. All right, so you see this table here. What I want you to do is I want you to fill it out. So you've got to, I'll show you what we're doing here. Here are the names. So sometimes you have the name. Here are the atoms in the compound. And here is the formula. Okay. So if the formula is blank, so in this first one, you've got the name and you've got the atoms in the compound, you've got to write the formula. In this one, you've got the formula, you've got to tell me what atoms are in the compound and what the name is. In this one, you've got the number of atoms in the compound. You've got to tell me the formula and the name, and it's the same for this one. So I want you to pause the video and have a go at that now, please. So don't play it until you have the whole table done. Okay, so let's have a look at how you got on. So the first one is water. It has 2 hydrogens and it has 1 oxygen. So the way we would write the formula for this, I'm going to write it here in red. I'm just actually going to rub out these stars, write it here in red. We've got 2 hydrogens. So the symbol for hydrogen is a capital H. I just need to make my pen a bit thinner. We've got a capital H for hydrogen, and there are 2 of them, so it's going to be H2. And there's also an oxygen, so H2O. And we've definitely seen that formula before, I'm sure, for water, H2O, but now you know where it comes from and how we figure it out. So H2O is the formula, chemical formula for water. All right, the second one, we've got the formula and we need to know what atoms are in the compound. Well, first of all, there's a Ca and there's no number. Okay, so this is 1 calcium. So Ca is calcium. And we also have this guy here, an O with no number, so 1 oxygen. So the name of this substance is actually going to be, well, the metal here is calcium, so it's going to be calcium oxide. Great job if you got that right. Next one, we have the number of atoms in the compound, and we have to write the formula and the name. So let's write, I'm going to do the formulas first. So potassium and oxygen. So we've got 2 potassium. So K is potassium, and it's going to be K2 because there's 2 of them, K2O. Now, what if you did this, OK2? Is that okay as well? Actually, okay, that's kind of funny, but is that correct as well? Is a better way of saying it. Well, the answer is, like, it's not terribly wrong, but usually we have an agreement among scientists that we put the metal first. So the metal is potassium, the same as what we put the metal first in the name over here. When we name it, we're going to name this potassium oxide. We just have this agreement that we're going to put the metal first. So potassium is a metal and oxygen is a non-metal, so the potassium should come first. Okay. What about aluminium and oxygen? So we've got 2 aluminiums and 3 oxygens. Okay, so this is going to be Al is aluminium, and we've got 2 of them. So Al2 and 3 oxygens, O3. Well done if you got that right. And the name here is going to be aluminium oxide. Again, fantastic job if you got that right. Okay, so if you could do all of them, then you are absolutely flying. We're just going to learn a little bit more today. Okay, what we're basically going to talk about now is we're actually going to talk about, well, why do we know how to write a word equation for a chemical reaction now? We know how to write the name and the formula for compounds. But the next question is, well, why do these things react at all? What is it? Why do some things react when we put them together and other things don't? Why do atoms want to join together to make compounds? Now, to answer this question, we're going to have a look at our periodic table again. So I'm going to bring this periodic table just over here where I can see it. I don't want to block up my whole screen. Yeah, that's about right. Okay. Right, to answer this question, we need to look at a specific group on the periodic table, and that is this group here. This group here. So I'm highlighting a group on the periodic table. Now, this here is group 0 is what it says, but I like to call it group 8. And again, scientists sometimes don't agree on this. Some scientists like to call it group 8. Some people call it group 0. You'll see why I want to call it group 8 in a minute, I hope. But this group are really important. I'm going to show you why. We're going to just quickly draw out the structures of the elements in this particular group. So I'm going to pick the top 3 elements in this group. They are helium, He, neon, Ne, and argon, Ar. Now I'm just going to bring you back over here and show you them. Here we've got helium, He, neon, Ne, and argon, Ar. All right, why are these guys important? Well, we're just going to figure out why they're important, we're just going to draw their structures. All right, so we're going to draw these atoms. Now, I'm hoping that you guys know how to do this, if you remember. So we've got helium in the middle, and then we've got to draw the electrons. Now, helium has an atomic number of 2. Okay, so here is the atomic number of 2. That means it's got 2 protons, and it's got 2 protons, it has to have 2 electrons. So I'm going to draw them here and here. There's our 2 electrons, and that's 2 electrons in the first shell. It's got an electronic configuration of just 2. Neon has an atomic number of 10. That means it's got 10 protons, and if it's got 10 protons, it's got 10 electrons. Here is 2 in the first shell, and it's got, I've got to put 8 more. So I'm going to open up a second shell, and I'm going to put 8 into the second shell. So this has an electronic configuration of 2, 8. Argon has an atomic number of 18, which means it's got 2 in the first shell. It's got 8 in the second shell, which is now full. And of course, it's got 8 more because it's got an atomic number of 18. And it's got 8 in the third shell, like this. So it's got an electronic configuration of 2, 8, 8. Now there's something very special about the structures of these atoms. Okay, well, these atoms are extremely what we call stable, okay? And this is because if you look here at the outermost shell, so helium has only got 2. He's only got 1 shell. It's got 2 in it. It's got a full shell. Neon has 2 shells, and in the outer shell, this one on the outside here, it's got 8. And we know that that's the most that the second shell can hold. So it's got a full outer shell. It's full. Okay. This one, it's only got 1 shell and it's full. This one also has 8 in the outer shell. Sorry, my screen is crashing. I'll have to pause this for a second. Apologies. And we're back. This one here has 8 electrons in the outer shell, and as you can see, these 8 electrons here mean that this third shell is also full. Okay, so we've got 3 atoms all in the same group, and they've all got a full outer shell. Okay, so the first one has 2, and that's full. The second one has 8 in its outer shell, that's full, and the third one has 8 in its outer shell, that's full. Now, this is a really, really, really important idea that you understand as a scientist, is that atoms who have full outer shells, the outer shell is full, these are very stable. It means they don't want to react. They don't have any interest in reacting. Chemistry is all about the movement of electrons from one atom to the other. When things react, electrons move from one atom to the other, or they get shared between atoms. You're going to see this in the next couple of lessons. But the key idea is they're doing it so they can be more stable. They're trying to be like these elements. These elements are really stable. So there's a rule here, and that is to be stable, atoms must have a full outer shell. So the most stable atoms are ones with a full outer shell. And these gases, all of these are gases in group 8, they have the nickname, the group 8 elements have the nickname, the noble gases. And noble just means like they don't react. So the noble men or the noble people back in the day were like people known to be very calm. They don't react. They don't like get angry at things. They're known to be kind of upper class, kind of don't get angry at things, and they're just unreactive. That's where the word came from. So noble gases. So this group here, group 8, are the noble gases. They are very stable and they don't do any chemical reactions. So you'll notice all the word equations we wrote so far, none of them involve these things, helium, neon, argon. And that's because they don't actually react, because they are already very stable. So if something is reacting, so atoms are actually doing a chemical reaction, it's that they're trying to be like this. They're trying to end up with their electrons, so they have enough electrons that they have a full outer shell. So these noble gases, these atoms, they do not gain, which means get more, lose, or share electrons with the other atoms. And that is what chemistry is. Share electrons. They do not gain, lose, or share electrons. Chemistry is all about, chemical reactions are all about atoms gaining, losing, or sharing electrons. And that's so that they can be more stable like these guys. Okay, so that's a really important idea, because we're going to be talking in the next lesson about, what actually happens when things react. Where do what do the atoms do? Why do they stick together? Why do chemical bonds form? And that's all got to do with these electrons, believe it or not, and especially these electrons in the outer shell. The ones in the inside shell, so like these electrons here for this atom, these are really not involved in chemical reactions at all, because these are tucked away inside. If you imagine 2 atoms coming together, it's not going to be these ones in the middle that are coming into contact with each other. It's going to be only these ones on the outside. Okay, so like these ones in the outside shell. If this bumps into another atom, it's the electrons on the outside that are close to another atom and they can interact. Whereas the ones on the inside, they can't really do that. So the key thing in here is atoms and elements react to try and be like these guys. These guys are really, really stable. because they've got full outer shell. That's a really, really important idea, okay? All right, let's do some questions on that now, okay? So have a look at these. Let's do question 1 first. It says, below is an atom of oxygen. So study the diagram carefully. Could this atom be described as highly stable? So yes or no. All right, so I want you to pause the video and say, what do you think? Could it be described as highly stable? Is that true? Yes or no? Okay, so you should only listen if you've written down an answer to number 1. And I'm hoping that you wrote down no, it's not highly stable. You're looking at its electronic configuration. You're looking at where the electrons are. It's got 2, 4, 6 electrons in the outer shell. And I just told you that that's not stable. We know how many is stable. We know it. Okay, so that's going to be the next question. I don't want to give you the answer. So I think you should be able to finish the rest of these now. So pause the video now and do 2, 3, and 4. Okay, so hopefully for this second one, you said what makes an atom stable? You should have said if they have a full, and you've got to say this word outer, it's the outside one, outer shell, full outer shell. Just to be clear where the full outer shell is, I probably didn't point this out again, but I'm hoping that this one here is the outer shell. This one here is the outer shell. This one here is not the outer shell. This is like the second shell here, but it's not the one on the outside. Okay. This one here is not the outer shell. This one here is the outer shell because there is only one. Okay. All right. Let's go back to the questions. Okay, they're stable if they have a full outer shell. Again, I'm only telling you what you should have. That's not a full sentence. You should have a full sentence written. Which group of elements are highly stable? So this is group 8, or what we call the noble gases. You could have also said group 0. Okay, that's technically correct as well. And then use your periodic table to name 3 stable elements. So hopefully here you looked at group 8 and you named 3 of them. So the 3 I showed you were helium, neon, and argon. There are other ones in there like krypton, I think xenon. I don't even see these ones very often down the bottom. Xenon and radon. Any of those are pretty stable, but especially these first 3 are really, really stable. All right, that's it for today's lesson. Okay, so you learned today, first of all, what is a chemical formula and why do elements react, and why are certain elements very stable and certain elements want to react. They want to be like these guys. They want to be like the noble gases. They want to have a full outer shell. A full outer shell means atoms are very stable and they don't react. Any atom that does not have a full outer shell will react to try and get a full outer shell. Really important idea. All right, that's it, guys. I'll see you in the next lesson.